Okay, guys, this is going to be section 10.6 through 10.7, finding the volume and the surface area of spheres. So you should know what a sphere is based off of your middle school math. Here's a couple of examples. And so let's talk about the parts of a sphere, or actually the formal definition. The formal definition is basically the set of all points, a given distance from a given point, called the center. So it's infinitely many points that go all around the same distance from the center, okay? That distance that all these points are from is called the radius, okay? So that's the distance from the center to any point on the sphere. And so there's an example right here in blue. And then we also have what you call is a chord. This is a segment with its endpoints on the sphere. So here, if you're looking at a diameter in green, that's represented as a chord, okay? And actually this one right here in orange, that's a chord as well. Now, I kind of jumped the gun. The diameter is also a chord, but more specifically, that's going to be the chord that passes through the center. Okay, so both the green and the orange segment are both chords, but the green one specifically is the longest chord. So if you want to write that down too, this is the longest chord in a sphere. All right, so that's for the diameter. Okay, so let's talk about the formulas. There's two formulas, one for the volume and one for the sphere. So the volume formula with the radius r is going to be volume equals 4/3, 4/3 pi r cubed. And then the surface area formula is going to be 4 pi r squared. So pretty easy formulas. Now I want to point out that there's a big difference between each formula because kids in the past have often mixed up the two. This is a cubed for volume, and this one has to be squared for surface area. So let's go ahead and start putting those two formulas to use. Okay, so let's start off with this one right here, finding the volume of this sphere. So the first thing you want to do is write down your formula, 4/3 pi r, which is 4, and then cubed. So 4/3 pi r cubed. So let me get my calculator ready. So 4 cubed is 64. And then I have 4/3 that I'm just going to put out in front, and then I'm going to move pi to the end because I like leaving my answer in terms of pi. So I'm going to do 64 times 4 divided by 3, which is 85 1/3. It's 0.333 repeating, but I like to leave it in exact form. So if I ask for the exact answer of the volume of this is going to be 85 1/3 pi millimeters cubed, okay? And that's it. So let's go to this next one. This next one, we're finding the surface area. SA always stands for surface area. So it says, what is the surface area of the sphere in the box? Oh, if the box has the dimensions of 10 by 10 by 10. So that's 10, and the depth is 10. Well, you see these little points right here. Let me highlight those in yellow. These points right here, those are on the edge of the box. So anytime you see that right there, those are on the edge of the box. So basically, what that's telling you is that this length right here is how big? The same as this, which is 10. This length right here is as big as this length right here, which is 10. So the diameter of the sphere is 10. So if the diameter of the sphere is 10, What does that tell you about the radius? The radius is always half of the diameter, so that's 5. So now we want to write down our formula for surface area, 4 pi r squared, which r we just said was 5 squared. So we know that that's 25. We have a 4 out in front. I'm going to move the pi to the end because I like to leave my answer in terms of pi, 100 pi. So the surface area of the sphere inside that box is 100 pi inches squared because we're doing surface area. Let's go to the next one. On this next one, we have what you call is a hemisphere. And so it says the area of the base of the hemisphere. So let's highlight the base. The base of the hemisphere is always going to be the flat surface right here. Okay, so I'm going to highlight that in pink. So there's the base. So the base is the area of 225 pi inches squared. So area equals 225 pi inches squared. So in order to find the volume, remember our formula is 4/3 pi r cubed. I need to figure out what r is. So what should I do with 225 pi? I should set that equal to, well, what is the shape of this base right here? What is the shape of that base? It is a circle. So I'm going to do pi r squared equals 225 pi. And so what happens to the pi's? The pi's will cancel out. So then I have r squared equals 225 pi. If you're wondering why the pi's cancel out, think of it as if you would divide by pi over here, and it cancels. Whatever you do to one side, you have to do to the other. So you're dividing pi on both sides. So r squared equals 225. How do you solve for r? You square root both sides, and you get r by itself. The square root of 225 is 15. Okay, so there's my r. This is important. This is what I need to do my formulas over here. So let's finish off our volume now. So we're going to do 4/3 pi r cubed now. One thing that you need to remember is that this right here is for a full sphere. Do we have a full sphere here? No, we don't. Okay, so you can choose to do this and then divide by 2 at the very end, or you can take half of it at the very beginning. Okay, so there's 2 different ways you can do that. So I'm going to stick to the formula, and then I'm going to divide by 2 at the end. But like I said, you can do it whichever way you want. That's the great thing about math. So I'm going to put 15 cubed right here. So 15 cubed in the calculator is 3,375. Put pi at the end, and I have 4/3 right here. So I'm going to take the 4/3 of that times 4 divided by 3. So 4,500 pi. Okay, so remember, this is for a full sphere. Okay, that's for a full sphere. So I don't want a full sphere, I want only half of a sphere. So I'm going to divide it by 2. So 4,500 divided by 2 is 2250 pi. Again, I like to leave my answer in terms of pi. So I'm going to leave my answer in terms of pi. So 2,250 pi. And do we have any units here? Forgot to check that. Inches. Inches cubed. All right, so there's the volume of this hemisphere. Now let's go on to surface area. Surface area is 4 pi r squared. Okay, now that is for a full sphere. You have to think about this is not a full sphere. If you look and focus on just this top part, that is half of a sphere. okay? But don't forget, we have that base on the bottom that is also a surface. Think about what this means, surface area. You always want to think about what you can paint, because that will kind of help you figure out all the surfaces that you need to find the area for. Because if you can paint that surface, then that's part of the surface area. So I need to take half of that, but then I need to add the surface on the bottom, which is in pink. So I'm going to write that in red. And what is the surface on the bottom? A circle, which I know the area of a circle is pi r squared. So let's simplify this formula, and you can see what it reduces to. What's half of 4, everybody? Oops, I'm jumping the gun. That is 2 pi r squared plus pi r squared over here. So what's 2 pi r squared plus pi r squared? 3 pi r squared. So guess what, everybody? This right here is the formula for the surface area of a hemisphere. Okay, this is always going to be for a hemisphere. So now let's put our formula, last step to the formula. Let's see, R is what? 5? No. What was it? 15? So R is 15. So let's go ahead and 3 times pi times 15 squared. So 15 squared is 225. 3 times 225 times pi. So 225 times 3 is 675 pi. And that is our surface area for this, okay? So I'm going to go highlight some things here. You need to take note of these right here, okay? Remember, we had to take half of the hemisphere formula. The sphere formula to make it a hemisphere. But then we had to add the shape at the bottom, pi r squared. So then it ended up ultimately being basically 3 pi r squared for the surface area of a hemisphere. Always, all the time, okay? So let's write our final answer. Again, I like to leave my answer in terms of pi, so I'm just going to leave it up there. So this is 675 pi inches squared, because this is surface area. All right, that's the hemisphere. Let's take a look at one more. I think that's the last one. Nope, 2 more. What is the length of the radius of a sphere if the volume is 236 cubic feet? So if I'm finding the length of the radius and I know the volume, I want to write down my volume formula. 4/3 pi r cubed, okay, equals the volume. Well, they gave us the volume, so I'm going to plug in 236 pi into V. And then I have 4/3 pi r cubed. So basically, from this point on, this is an algebra problem. How do I get r by itself? So I want to eventually get r by itself, and then that'll get me my answer. So I have to first start off by getting rid of the 4/3. How do you get rid of the 4/3? Okay, you could get rid of the pi's first too. So let's actually do that, because I bet most of y'all are probably eyeing that. If I divide by pi here, that means I have to do it over here. They cancel out. So now I have 236 equals 4/3 r cubed. So now I just have to get rid of the 4/3. How do you get rid of the 4/3? I want to multiply by 3, and that'll cancel the 3's out, but I want to divide by 4 at the same time. So if you think about it, you're multiplying by the reciprocal of 3/4. Whatever you do to one side, you must do to the other, okay? So again, you can do that in 2 separate steps. Multiply by 3, and then divide by 4. But just know that you can get it done in one step if you multiply by the reciprocal. So we're multiplying by 3/4. So what is 236 times 0.75, which is the same thing as 3/4? 177. Okay, so I'm going to go to a different color. So this is going to be 177 equals r cubed. Okay, so at this point, here's where a lot of kids forget what to do to get rid of the cube. Think about when you used to do a Pythagorean theorem, 12 equals c squared. You square root and you square root to get rid of that. Well, for this one here, what you do is you cube root to get rid of that. You cube root, okay? So if you look on your iPhone calculator, I'm going to put 177 in my calculator, and if you look to the left, there's a cube root symbol, and it should get you 5.615, and that is your radius. Okay, so that's really the new part right here. So I'm going to highlight that in yellow right here, this cube root situation. Okay, that's the cube root situation. And so that's the only new part that you'll need to kind of remember. And it's on your calculator. You don't have to do anything by hand. Okay, so there's the radius. All right, last one. It says lobster fishers in Maine often use spherical buoys to mark their lobster traps. Every year, the buoys must be repainted. An average buoy has a 12-inch diameter, and an average fisher has about 500 buoys. A quart of marine paint covers 175 square feet. How many quarts of paint does the average fisher have? So let me get my pen. It's not a crayon. All right, so every year the buoys have to be repainted. So when we're talking about paint, what do you think we're doing here? We're doing surface area, okay? A buoy, if you're not sure, is a circular sphere that goes in the water and it floats, okay? So a surface area of a sphere. And then it says an average buoy has a 12-inch diameter. So I want to mark that on here. From there to there, it's 12 inches. And then it says an average fisher has about 500 of these. So 500 of those guys right there. It says a quart of paint covers 175 square feet. I want to highlight that right there. So 1 quart covers 175 square feet. I already see a red flag right there. We just talked about this being in inches, and we need to make sure we turn that into feet. So good thing this is a nice pretty number. So that thing right there is 1 foot. Okay, so 12 inches is the same thing as 1 foot. How many quarts of paint does an average fisher need each year? Okay, so we got to paint 500 of these. It has a diameter of 1 foot, and I got to do see how many quarts of paint we're going to need. So I'm going to find the surface area of 1 sphere. And so what's my formula, everybody? It's going to be 4 pi r squared. So 4 pi, what is r? R is going to be 0.5 feet, okay, 0.5 feet, because we have to leave it in feet in order to take care of that last step. So 0.5 squared is 0.25 times the 4, and then I have pi. What's 0.25 times 4? Looky there, it takes me back to 1. So 1 pi is the surface area of 1 buoy. Okay, well, how many buoys do I have? 500. So I want to times that by 500. Okay, so what's 100 times 1 pi? 500 pi. So surface area of all these buoys is 500 pi. So now this is the total surface area. Now I want to take this number and divide that by 175 square feet, because remember, this is 500 pi square feet. So I'm going to take 500 times it by pi in the calculator. I get 1,570 divided by 175, and that equals about 8.975 quarts. So this equals about, let me move this right here. So 8.976 quarts. And so it says, how many quarts of paint does the average fister need? If we wanted to, we probably should just go ahead and round that up to 9 quarts to be safe. Okay. So 9 quarts is our final answer. Okay. If you put this answer right here, that's still correct as well. All right. That is